my confidence in my typing is off from my putting the negative on another problem. Okay, so 588 newtons is equivalent to, is the weight or the force created by a 60 kilogram object. Now honestly, you can just do this problem by taking your 588, that's your force, and multiplying it by how far it moved, which was 2 meters, and we would get 1,000 plus 160, 1176, okay. And again, Newton meter, or if, you know, you can also say joules, it's the same unit. So you can just, with that kind of problem where you just have a force and a straightforward distance, you can just literally multiply the force by your distance and get your answer. Some of the problems we're going to do, though, the force changes incrementally, and so you can't just take a single number representing force and multiply by a single number representing distance. And so the reason why it's covered now in calculus is because those type of problems do involve setting up integrals. I have an integral set up on your notes here because all of the problems can be set up with an integral. In this case, you've got a constant force, so my function that's representing the force is the constant 588, and if you thought about, the, you know, if you were able to film the weightlifter with a slow motion camera, you could kind of watch how he incrementally lifts it, and so the dx is representing incremental little distances, and so you're adding up a whole bunch of incremental force times distances, and my distance is going from 0 to 2. If we find the antiderivative of a constant, it would just be 588x, and then I'm evaluating that between 0 and 2, and so you get your same answer that we got up there. Okay, so what that integral is representing is you have a single constant force, and if you moved it from 0 to 2, you could picture yourself doing it incrementally, and every one of those little increments would be a certain amount of work, and then you're adding them all up. And we know that by now that this symbol means it's a sum of incremental measurements, and it's the limit as you're making the incremental change smaller and smaller and smaller, and the fundamental theorem of calculus kicks in, and so this value is equivalent to the area under this curve from 0 to 2, but in this case it's also representing our work being done. Okay, so I'm just explaining why I bothered having an integral there, but you could correctly answer this question by just taking your 60 times 9.8 to get your true force and then multiplying it by the 2. Okay, problem number 2.